not is there in the. Next, Nana, come to the elevation of the boiling point. So I already told you this is more than enough because the total entire thing is, it's nothing. That's coming in last. Right now, next, the elevation in the boiling point. So I'll go a bit fast now onwards. It's easy now. So what is our intention? To know the unknown solute molecular weight. Okay. Vanshika, are you there? So now same, take pure solvent. Pure solvent, say its boiling point. Now, pure solvent boiling point. So what is boiling point? I told you, when we are heating, so the vapor pressure of solution is equals to atmospheric vapor pressure. Simple. So imagine this is pure solvent, the boiling point is T0 B. B means boiling point. T0 B means what? Boiling point of pure solvent. Boiling point of pure solvent. See now, here is for example, outside is 6 are there, right? Hello? Sir. Sir, అది క్లాస్ ఇంకా ఇక్కడే ఉన్నారు సార్, ఇంకా వెళ్ళలేదు. ఇంకో కొంచెం ఎండింగ్లో ఉంది టాపిక్, అయిపోతుంది. వెళ్ళిపోయాడేమో, లేట్ అయిపోయింది కదా. రైట్, ఎలివేషన్ ఇన్ ద బాయిలింగ్ పాయింట్. ఫస్ట్, ఇస్ ఇట్ క్లియర్? నౌ imagine atmospheric law, in atmosphere 6 particles are there. Imagine here onwards how many are there? 6 are coming. So boiling point is clear. So now what we need to do? We need to add the non-volatile solute which is given to us to know its boiling point. So imagine it occupies, right, some space on the surface, the non-volatile solute. So imagine this boiling point is 100 degrees centigrade. So when I'm adding the non-volatile solute, its boiling point, what happens? Boiling point, what I'm speaking. Boiling point, what happens? Vanshika, Neeraja? Increases. Why it increases? So two things are there. Elevation in the boiling point. By default, elevation means elevated. Like that also we should know. Otherwise, this is a logic. Outside 6 are there, so from inside also 6 should come. But what exactly happens is outside 6 are there, but here is how many are there? Only 4 are coming. But to equal means we need to increase the temperature. Both should be equal, right? Outside 6 are there. From here 4 are only coming. Why 4 only coming? Because of the non-volatile solute. So means simply boiling point is here is TSB. Nana. What is this? Boiling point of solution. What is elevation in the boiling point? Delta TB, nothing but elevation in the boiling point. We consider delta TB is equals to what? So it will be somewhat 120, 130 like this degree centigrade. So TSB minus T0B. This is elevation in the boiling point. Don't confuse T0B minus T0S because elevated, right? So experimentally they determine that delta TB is directly proportional to molality of the solution. So delta TB is equals to proportionality constant, Kb, ebullioscopic constant or molar elevation constant, Kb into m. Delta TB is equals to Kb into weight by molecular weight into 1000 upon grams of solvent. Molality I told you, grams of solvent. So this is a formula. Delta TB is equals to KB into M. So now what they'll ask? What they will ask? This one. Everything remaining things, T0 B, T0 S and everything they'll mention. So this KB is nothing but molar elevation constant or molar ebullioscopic constant. Ebullioscopic constant, molar elevation constant. Clear? So remaining everything they'll give. Just we no need to take anything. Just simply we need to know the formula. We need to substitute. Completed? Vamshika is clear? Any doubt? Tell that's all. First concentrate on the what is our main essence, so then afterwards we'll go. Kelvin kg per mole from delta TB by M. From that we'll get. This is Kelvin. This is kg mole per kg. Like that, the latter we'll get. Right. So elevation in the boiling point. Try to understand in this case. Right. So which one, solvent or solute? Which one boiling point is higher? Solution. Solvent boiling point is here. Solution is somewhat higher. So the difference is delta TB. When we are adding the non-volatile solution, the boiling point is increases. Means vapor pressure both are equal that case. Okay. So KB value, Nana. So KB value, write it down. Or T0 B into M 1000 by delta HPP. So I told you, right? Units. Kelvin per mole. Nothing but Kelvin kg per mole. So by heart cheyadu direct akkadi nunchi raavali. So this KB is purely depends on the solvent, right? So boiling point of pure solvent, right? Molar mass of the solvent from that one. So KB value from solvent, because heat of vaporization from that we derived that. From the thermodynamics it's coming, it's a constant. So they'll give the constant value. So we no need to calculate and all. Got it? So sometimes it's needed, but majorly in the numericals they are not asking. I value I will discuss later. No. Next, depression in the freezing point. Depression in the freezing point. So same, our intention should be same. Okay, what is our intention? Unknown solute molecular weight, take pure solvent, same pure solvent. So T0 F, Nana. What is T0 F? freezing point of pure solvent. So everything is same. Add the non-volatile solute. Imagine this is 0 degree centigrade freezing point. When we are adding the non-volatile solute, what happens? Its freezing point TSF. So -5 or minus something, right? What is depression in the freezing point? Vanshika? Delta TF. Vanshika? Hello? Are you there? Hello? Vanshika, is it audible or no? T naught F minus TSF. Because this is higher value, this is lower value. When we are adding the non-volatile solute, the freezing point is decreases. That's the reason in cold countries, if the ice is on the road, they'll spray some salt. Because the freezing point is decreases, the ice will melt. Right? Whenever we are adding depression, by default also we need to understand. So there is a reason is there when we are adding the same vapor pressure concept. So that is not needed actually. So delta TF is directly proportional to molality. Delta TF is equals to KF into M. Delta TF is equals to KF into weight by molecular weight into 1000 upon grams of solvent. Write it down. Same. Once again we got here what? Molecular weight. Clear? Vanshika, Neeraja ఉన్నావా? అడిగినప్పుడు చెప్పాలి అప్పుడప్పుడు. వాయిస్ క్లియర్ ఉంది కదా? Then this is about depression in the freezing point. Same delta TF. So and one more important thing, what is delta TB and delta TF now? Delta TB is equals to what? TSB minus T naught B. But here is T naught F minus, this is a difference you need to understand. And see now, delta TF is equals to KF by KF into M by delta TB is equals to KB into M. MM cancel, right? Delta TF by is KF by KB also we can take it. So that later so you can do that. Next last one is osmotic pressure. Osmotic pressure. The last one, so osmotic pressure. What is osmotic pressure? Osmosis. First we need to know the osmosis. First, semi-permeable membrane. Semi-permeable membrane is two types. One is natural, one is artificial one, which allows only solvent. Write it down. Which allows only solvent. Which allows only solvent. For example, here is solution, here is solvent. Always solvent moves from high solvent region to low solvent region. So here is solvent is only pure solvent, here is solution means solute plus solvent. So now the solvent moving this side. Got it? Because here is more solvent, right? Here is more solvent, here is less solvent. Got it? Imagine sometimes here is high concentrated solution, semi-permeable membrane, this is low concentrated solution. So which direction it moves? Left to right or right to left? Concentration, high concentration means more solute, right? more solute. Low concentrated means low, less solute. Less solute means what? More solvent. So now solvent moving from which direction? Right to left. Concentration, I'm not speaking about the concentration of solvent, concentration of solution. Concentration means it depends on solute, not solvent. So like that. So don't confuse. So let it be. Now it's very simple. In case of here, I'm just taking the semi-permeable membrane. Right here, I'm just taking one piston, movable piston. We are applying some pressure, but nothing but osmotic pressure we will say with pi. Okay. It is solvent, it is solution. So now the solvent will move which direction? Left to right, right? Yes or no? Because it is more solvent, it is less solvent. So now, Vanshika, clear? Neeraja? This is the thing, so we are applying some pressure. We are applying some pressure to stop the flow of solvent. That pressure we are called as osmotic pressure. What is osmotic pressure? We are applying some pressure to stop the flow of solvent. Right? That we are called as osmotic pressure. Imagine if I am applying more than osmotic pressure. So RO, reverse osmosis. The reverse osmosis, what happened? Whatever the solvent is there comes this direction. So our purifier, water purifiers, this is solution means with right RO systems, reverse osmosis. In the, for example, salt solution, whatever the solution is there, we are applying high pressure. What exactly happens? Only right solvent is coming this direction. Right? That is called as RO, reverse osmosis. Reverse osmosis. Okay, na? Imagine, right? Here is solvent, here is solution. How the solution came here? Whatever we added the solute, whatever we want to calculate, we just adding here, it becomes solution. Pure solvent, solution. So based on that, osmotic pressure purely depends on the how much solute we added. Based on that, it's different. So here is pi is equals to, directly write it down, want of is a scientist, pi is equals to CRT. C means concentration. Concentration nothing but what? Number of moles by volume. So pi is equals to N by V RT. Pi V is equals to nRT. Pi V is equals to N means what? Weight by molecular weight RT. So we got that molecular weight. Write it down. If two solutions are same osmotic pressure, pi 1 is equals to pi 2, that we are called as isotonic. If pi 1 is greater than pi 2, this is hypertonic, this is hypotonic. Hypertonic, hypotonic. So colligative properties are easy only. The problem is we will make it in a confusion mode. But in all the cases, the main intention is that only. So last topic now, ACP. So ACP. What is ACP? Abnormal colligative properties. I told you when we are adding the solute, it should not undergo association or dissociation. Imagine, for example, NaCl, if I am adding the 100 NaCl molecules in a solution, it becomes what? Na plus Cl minus. This is 100, this is 100. Whatever we have calculated, right? we are calculating for 100, but in the solution what happens? Na plus Cl means 100 plus 100, 200. I told you in the beginning, colligative properties depends on number but not nature. So it's only here is 200 we are calculating, but not 100. Association, sometimes association is also takes place. For example, CH3COH 100 I'm taking, right? It becomes the double bond OH, the OH double bond O, CH3. Association is takes place. So I'm taking 100, it becomes 50. 2 becomes 1. Alright? Association is takes place, dissociation. When solute is undergoing association or dissociation, that cases whatever the colligative properties we are calculating, or whatever the molecularity we are calculating, so it is invalid. To correct this one, Van 't Hoff is a scientist. He has introduced one factor that is nothing but I, Van 't Hoff factor. So if I is equals to 1, no association, no dissociation. If I is equals to less than 1, association is takes place. If I is greater than 1, dissociation is takes place. I is equals to less than 1. Okay? Now try to understand the last concept, almost all done. The colligative properties are inversely proportional to molecular weight. Molecular weight, yes or no? See, Nana, in this case, this is a pi is a colligative property inversely proportional to molecular weight. So delta TF is a colligative property inversely proportional to molecular weight, right? Inversely proportional to molecular weight. All the cases inversely proportional to molecular weight, right? So for example, I is equals, they gave like this, right? Normal molar mass, normal molecular weight or molar mass by observed molecular weight or observed molar mass. So this is a formula they gave us. Otherwise, from this one, I is equals to what we can write? Right? Observed colligative property by normal colligative property. Because both are inverse relationship. Normal means, for example, acetic acid. The normal molecular weight is how much? 60. Observed weight is how much? 120, right? Dimerizes, right? 120. So 60 by 120. So 1 by 2, nothing but 0.5. I is equals 0.5 means what? Right? Less than 1. Less than 1 means association, like that. Sometimes they'll give some observed colligative property. Normal colligative property we need to calculate through that one. So from that one I will get the I. Got it? They'll give some experimental value. We need to calculate from that one. We need to calculate the I value. For example, NaCl is 100% dissociation is there. For example, N is equals to 1 rho. Alpha is equals to 100%. Alpha is equals to 1 means what? 100% dissociation. So here is directly that in case of dissociation is takes place, right? Degree of dissociation is takes place. Alpha is equals to I minus 1 by N minus 1. Write it down this. Degree of dissociation is takes place. When the degree of association, derivation is there, that not needed. Okay. Alpha is equals to I minus 1 by N minus 1. What is alpha? Degree of dissociation. Here is what is alpha? Degree of association. What is N means what, Nana? Number. For example, NaCl. N is equals to 2 rho. MgCl2. N is equals to 3. If 100% dissociation is takes place, directly we can take N value. So n number how many number based on formula we'll write. So now from this one I value will calculate, okay, based on degree of association or dissociation they'll give the value. Now what we will do, P naught minus Ps by P naught is equals to I into x2. Delta Tb is equals to I into Kb into m. Delta Tf is equals to I into Kf into m. Phi is equals to ICRT. Into I, simply we need to add. This is the correction of the association. When association dissociation is taking place, we need to add I. If there is no association, no dissociation, no I, directly we can use it. Got it? Already I told you, if no association, no dissociation means I is equals to 1. Simple. Vanshika, समझ गया? This is all about the solutions in the overall view. So now what you have to do is first go through the NCERT. NCERT, just scan it and go through the numericals. Just scan the numericals, also don't solve, just scan it. What they are asking, how they solved. What they are asking, how they solved. So already we know the concept, right? For example, I will show you one questions, a couple of questions from NCERT. Okay. For example, solutions, Nana, directly. So just go through the line to line, okay, and whatever the questions are there in text questions, just see it first. So then afterwards goes to the previous year questions and again. So this is the KH values, they already give you. See, Nana, for oxygen 293, 34, 303, 46 means temperature increased, KH value is also increased. Just go through the NCERT and try to solve this type of questions. See it first. Previous year question P by Qs, student anni. First observe it. So then automatically we'll get a pattern. So P total, so P, I told you, right? P2 minus P1. So పెట్టేసే first student solve చేయకండి first don't solve, first understand, right? So once you got the clarity, so then solve it. If you don't know how to open that, first understand what I'm trying to say. But what we will do, so we could not understand, we'll try to open, it won't come. For example, now for example, this is relative lowering of vapor pressure. What the question they are asking? What is the molar mass of the solid substance? Got it? So P naught minus the vapor pressure of pure benzene at certain temperature, vapor pressure is given 0.80, or at non-volatile solute of non-electrolyte weighing 0.5 grams is added to 39 grams of benzene. Molar mass 78, vapor pressure of solution is given. What is the molar mass of solid substance? Is there clear everything? So now we can easily solve it, right? For example, the question, just see the question. So in this case, Kb, what temperature will boils at directly easy question. So calculate the, in case of boiling point, calculate the molar mass of solute and depression, elevation in the boiling point. Got it? So everything is we know, right? 12 is, so the boiling point of benzene is given. And when 0.8 non-volatile solute is dissolved in 90 grams of benzene, the boiling point raised to means elevation. Calculate the molar mass of solute. Kb is given. Is there any difficulty? First go through that one. Try to solve. Find out the molar mass, freezing point. Huh? So this actually I gave a different mode, but this everything is clear. In case of here, molar mass osmotic, by using the osmotic pressure also we have to calculate the molar mass. So degree association and dissociation, I told you I is equals to normal or abnormal mass observed colligative, because both are inversely relation. I is equals total number of moles. Based on that, we just calculated. For NaCl will take 2, right? Put the I values and we'll get that. Okay, so just solve it and try to see the different questions. First don't solve it, first try to understand, then solve it, so you'll get the clarity. First we need to know what exactly what we are getting and what, right? So compulsory one question is coming from this particular area, right? I hope this is clear, right? Thank you. Any doubts? Vanshika, Neeraja? నేను డైరెక్ట్ ఫార్ములాస్ ఇస్తాను, డైరెక్ట్ నేను పంపిస్తాను. అది డిరైవ్ చేయొచ్చు యాక్చువల్గా, కొంచెం టైం పడుతుంది, బట్ నార్మాలిటీ మొలాలిటీ ఇవన్నీ ఈజీ ఉంటాయి. దానికి ఏంటంటే దానికి ఇంత పెద్ద ప్రాసెస్ ఉంటుంది, డైరెక్ట్గా ఫార్ములా గుర్తుపెట్టుకో.